Hello all and welcome to my YouTube channel. So today in this particular video, we're going to be discussing about how we can detect a data drift, target drift, and how we can evaluate model performance once it has been deployed on the server or any other particular device where your model is being deployed. So we're going to be analyzing these kind of metrics like data drift and target data drift or model performance, and how it can be done. It's very pretty simple, and it has been directly been implemented in this particular evidently. So we're going to be using this tool. It's an open source tool which will help us to determine the data drift or concept drift in a particular model. So what happens in general scenario is, whenever you prepare a model or whenever you make a model with a particular data set, that particular model degradation happens over time. So that means your performance tends to decline as soon as the time progresses. So why this happens is because of two main things, that is called data drift, or we call it as concept drift. So, what happens in data drift is, generally the features that we have used for training a model, it gets changed. That means the statistics what we have used or whatever the data that we have used, it started getting changed over time. So your best model, which has been trained on a particular data set, is started changing because the new patterns has been evolving over the time. So that leads to the data drift. And in other scenario, let's say our variables are not changing, or statistics of variables are not changing, but our classes are being changed. So let's suppose when we have trained our old models, that was our best model and it was trained on three classes. Now the world has changed, and now it has been predicting the new classes. Like there has been a new classes which has been coming up, but model is still predicting the three classes. So in that case, a concept it has happened. That means a particular new category has been evolved over the time, and our model is still stuck in predicting those three categories. So these two things generally happen in the world, and that's how the model degradation happens over the time. And model has to keep in touch with the real world, like what is happening, and it has to be updated accordingly. So to measure these kind of data drifts and concept drifts, it become very difficult, and there are a lot of challenges to be applied. So this evidently open source tool will help us to determine the data drift and target drift, and even the model performance. So in this particular video, we are just going to focus on how to identify the data drift and target drift with just few lines of code, and it may not take much of the time to detect how it will be. So let's go to this particular GitHub of evidently, like what are the things they have applied. So you can see we can use it evidently to identify data drift, and this is how it's going to be looking. We can use numerical target data drift. So when we have numerical characteristics to be predicted, or let's say we have numerical columns to be predicted, so that data drift can also be detected, and it can also be shown over here. Even categorical target drift can also be detected. So let's suppose we have classification problem, and the categories has changed. So that's how a categorical target drift will be showing up, like has been a drift or there has been a change in the particular behavior. And we also have regression model performance. So it can help us to determine the old model performance and the current model performance, and we can also measure this by using this particular evidently. Even a classification model performance can be analyzed using confusion matrix comparison. So it's the old model and the new model that has been compared between these two. And similarly, the probabilistic classification model also uh, being compared inside this. So generally, it uses a predict probability functions which generally have in this particular machine learning models. So this is being compared based on basis of that. So you can see this is an old model which we have trained, or that has been trained already on the deployment, and this is the current model which has been deployed on the new particular classes. So you can see there has been proper separation between these two classes on based on the probability, and you can see there's a lot of difference, or there is a mixing of the probabilities. So that's how evidently will help us to determine a lot of things, a lot of comparison, and a lot of metrics to be uh, that is being analyzed while doing the model predictions, and while making the model into the deployment. So let's take a look onto this particular tool, and today we are just going to discuss about this data drift and target drift, and then in the later video we'll discuss how we can model, how we can check the model performance and how we can compare it. So now let's jump to the notebook. So here we have to just install evidently to quickly use it. So we're gonna just pip install evidently, and we're gonna use pandas, and we are just going to import dataset. So here in this tutorial we are going to use Boston dataset. That's a very primary dataset for our analysis, and we are going to import some of the libraries from evidently, and we are going to import some functions from evidently, that is dashboard. So to prepare a dashboard, we are going to import this particular dashboard function from this dashboard class, and we are going to import data drift tab. So because we want to analyze the data drift of the particular data, so we have to import this data drift tab. Otherwise, if you want to import, or if you want to analyze numerical data drift, or classified data drift, or model performance data drift, so there are other classes available, so you can import it directly from here. So that also can be done, but right now we are just going to focus on this data drift because we just want to focus on data drift. So that's why we are importing this particular class, which will analyze the data drift between the two particular data sets. And once the data drift has been detected, so we want to save it. So for that we are going to import the profile that will that will take all this data drift that has been detected, and it will prepare a profile, and that profile can be saved into particular profile sections by using this particular data drift profile section. So that is a general imports that we generally going to do in evidently, but you can just go into this particular github, and I can understand inside this particular docs of their particular evidently, you can understand what are things generally needs to be done to be uh, uh, to be uh, to be detecting the particular things. So right now we are going to focus on data drift. Likewise, you can do different kind of imports for detection into the particular model performance, or as well in the target drift or numerical category drift, right? So this is what generally evidently is all about, and the imports that it takes is just in line. So so let's just install this evidently. It will take few seconds, and let's just now import all these libraries, and let's load our Boston dataset, and let's convert that into pandas data frame, and let's just view some of the rows of this particular dataset. So you can see we have all these particular columns, and this is the prediction column. So that's what the data is all about. So you can see a lot of numerical things are happening. So to prepare a data drift or detect a data drift, two things you should be having. That is the old data set on which the model has been trained, that we called as a reference data set, and the current data set, like the new data set that is coming up. So we have to take this reference data set and the current data set, and we have to compare it to get the analysis of whether whether the data has been changed or not. So so here we don't have any reference data set or the current data set. So what we have done is we have taken a Boston frame, that is Boston data frame, and have taken 200 rows from the top, and the next 200 after 200 we have taken as an current data set. So this is acting as an this initial 200 rows are acting as a reference data set, and other rows are acting as an current data set. So here we have created two data set by just taking up some by splitting up the rows. So so we want to calculate the statistics between these two and detect whether the data drift is happening or not. So our main purpose is to understand like how the data drift is being identified. So that's how the calculation is being done over here. But if you want to use this in a real time, so you have to use the old data set, that is the old reference data set on which the model has been trained, and the new current data set. So likewise you have to mention it over here. So let's go it line by line. Now, what is being done over here? So we have imported a dashboard class, and inside the dashboard class we have tab parameter. So we'll import this data drift tab that we have also imported. So that's why we want to create a data drift tab. So we want to create a data drift. So that's why we are importing this data drift tab. So that's how the tab will be initiated and it will be present inside the dashboard. That's what this line is all about. And then once this dashboard program has been created, we want to calculate the particular data drift. So since we have provided the function that what needs to be calculated, so we have to use the calculate method, and we have to pass the reference data set and the current data set inside this. So it will calculate the data drift between these two reference and the current data set, and it will present the dashboard. So to present the dashboard, we have a simple function called dot show. So once the calculation has been done, we'll just do dot show. So it will show up the graph, or it will show up the particular dashboard, which consists of all the data drifts detected. And you can see we have this detected features are available. So you can see out of 13 features, 9 are rated as a data drift. So these are the features that we have used, and you can see the type of the column is numerical. So since we haven't specified any particular numerical or any column as in particular class or any category like numerical or even category, so generally this particular eventually takes all the column as numerical. So here we can see it has taken all the column as numerical, and these are the columns. So if you see, this is the reference distribution. So the reference data set coming from the reference data set, and this is a current distribution. That means it is coming from the current data set. And you can see data drift has been detected and the probability value. So you can see the distribution of this particular column or feature in this particular reference data set is different, and is here in this particular current data set is different. So that's why data drift has happened. So if you want to explore it more, you can click on this and you can see a particular data drift chart. So what does it shows is this green line is nothing but it's just an median line, which is or mean line or mean distribution of the current data set, or of the current data set, and it is showing the reference, and these points are the nothing but the reference points, right? So it is showing up the difference between the mean and the current points, and you can see the data distribution. So you can see a lot of data has been varied. So you can see reference is this, and current is in this orange color. So you can see in the reference we had number 2 as these main numbers of percentage of shares, but you can see in the current data set it has been decreased to this. So you can see there is a lot of difference in the data. So that's why data drift has been detected. And similarly you can view for other columns or other distribution charts, and that's how you can visualize the data distribution for each and every column. So this is how it has been done. Now let's specify some column as in categorical features, because when we have data which has numerical and categorical features, so how we gonna be doing that, how we gonna be specifying it, because by default this evidently takes numerical column as like all the column as numerical features. So in that case we have a function called column mapping that is being done inside this evidently. So what it does is we have to create a column mapping dictionary, and we have to map the column, like we have to uh, prepare a key in this particular dictionary of target, and we have to specify a value as target, and prediction column is something, but we don't have any prediction column right now because we're just analyzing the things. We don't have any model ran, so we don't have any prediction right now. So we have just created this prediction uh, key, and you have to just specify prediction column if you have any prediction model trained already. That is going to be looking in different video, but right now you can mention none. And we don't have any date time column, so we have mentioned none, but we are specifying the date time key inside this particular mapping. And since we have numerical features inside this, so we are going to mention a numerical feature key inside this particular dictionary, and we want to mention the names of the numerical columns, and we are going to specify some columns as categorical features. So we are specifying these two columns as a category features. So what will happen is it will calculate that it will calculate the data drift between these numerical columns and the categorical columns. So that's why we have defined it. So initially you have seen this particular column, it has been specified as numerical, but here we are specifying these column as an particular categorical. So this is how you can do when you have complex data set where you have numerical and categorical features. So you can prepare a column mapping, and you can specify the numerical feature key and category feature key, and specify the values as in column names. That's how you're going to do it. So let's just run it. And now the methods is similar to calculate data drift. So we'll just use the previously created function that we have created above, and use the calculate method, and we're going to pass the uh, reference data set, and we're going to pass the current data set, and we are going to use this column mapping argument, and we are going to pass this particular column mapping that we have created. So that's it. We just have to run this code, which will map or which calculate a difference between the numerical and the categorical data drift. So that's how it's going to do. And let's just put show function over it, so it will show up the particular dashboard of this particular created data set. So you can see now we have these features. These are column. Now you can see we have a categorical column is also coming up, and you can see now it has been treated as in categorical, and the differences has been shown over here. Now it is showing that derivative has been detected. So the analysis would be same if you open this particular column which is categorical, and you can see the similar kind of data distribution is happening, and you can even go into this particular values and understand this particular category of 0 or a categorical value of 1, how many times it has been identified in current and reference. And that's how the distribution is looking like in current and reference data for these particular categories of 0 and 1. And this is how you can understand the why data drift has been happening in feature wise, right? So that's how this evidently is helping to detect data drift and concept drift. Similarly, you can save all these particular profiles into the JSON format. So what you can do is you can just use this profile function that we have imported, and you have to mention what kind of profile section you want to detect. So we want to say that okay, detect a data drift profile section, and mention in this particular argument, and just let's just run this. So once you have specified like what kind of profile section you want to do or you want to store, the so you can just run the calculate function over this particular reference data set and the current data set, and you can use the column mapping that I have created. So it will just create a profile section for this, and then we have to just use .json to store it in a form of JSON. So sometimes this JSON format is required to get the numerical values, like these numerical values. Sometimes we need these numerical values actually that you want to see over here. So these numerical values has to be used. So what this profiling help us is it will store all these numerical values which has been there inside this particular graph. So you can see these values can be stored in a form of JSON, and this profiling section will help us to achieve that. So that's how you can see a lot of numerical values have been stored, and we can be used, and it can be used to prepare a different kind of graphs and whatever the things you can be doing with this particular JSON file. You can do the analysis. So this is all about this particular evidently tool for data drift. And in the next video we're going to be seeing how we can evaluate the model performance. We'll train some uh, dummy model on this particular Boston dataset, and we'll evaluate the model performance. right? So this is all about this particular evidently. So I hope you like the